All right, so we're now recording. And we go to share the screen. All right, so we're here. I'll do more problems from 1.2. I'll give you the quiz. Let's do it at 11:59. And somebody was asking, do I have to show up on quiz days, Fridays? No, you don't. It just means you get the quiz a little bit later by watching the video. Okay, so I'll show it to you in just a moment. So those of you that are here, you'll get it a little bit earlier than those of you that are watching it later this afternoon. But in any event, you have until 11:59 tonight to finish the quiz. So, you know, more than half a day for those of you that are here right now. All right, and reminder, you don't have to turn in any of the homework until the day of the test. So 1.2, 3, 4, 6, 7, 8, you don't have to turn in any of that until here. And let's see, I was just noticing something. Yeah, I kind of messed up here. See where it says 1.5? And there isn't any 1.5 because I'm actually skipping it. It was using technology to graph equations. That means use a graphing calculator or computer to graph equations. I was not going to do that, which essentially means these become buffer days. It doesn't mean it's a holiday. It means I'll just jump straight from 1.4 to 1.6. That's all. Okay, so that just gives me more time to do the rest of the stuff. All right, so first thing I'm going to do is show you the quiz. So those of you in this session, if you want to, it's on the video, but maybe you want to get it down first. So have your cell phones out or be able to do a screenshot. And I'll hold it up for maybe 30 seconds or so. And here comes the quiz. And sorry, I actually have to hold it. I cannot magnify this anymore except raising it up. Okay, so here it is. Take a screenshot, take a picture on your cell phone. Number one, solve the inequality and write an interval notation. X squared minus 5x plus 4 is greater than or equal to 0. So the first thing you want to do is factor, right? It's a pretty easy factorization. And then once you factor, whatever makes each factor equal to 0, those are your boundary numbers, right? So you lay down those points on the number line. There should be 2 of them. Decide whether those points are open or closed circles. I'll give you a hint. The original inequality is greater than or equal to. Okay. So I'm sort of helping you out with the quiz, as it were. Okay. And then test the regions. Pick a number in region 1, region 2, region 3. Work it out just like in class. And you get a sign chart, right? So I want to see the sign chart. This is positive, this is negative, whatnot. When I multiply a positive times a positive, or I got a positive times a negative, or negative times a negative, or whatever. Okay, and then is it true or is it false, right? And it looks like it says greater than or equal to 0. So of course, positive numbers are greater than or equal to 0. Negative numbers are less than or equal to 0. If the region is true, shade it in. If the region is false, don't shade it in. And then write the answer in interval notation. So you might have brackets, you might have parentheses, you might have negative infinity, you might have positive infinity. Right? So if you go all the way to the left, that's negative infinity. If you go all the way to the right, it's positive infinity. And positive infinity and negative infinity always use parentheses. Right? So look at all the hints I'm giving you, right? 2, same thing, it's a fraction, but same thing. What number makes the numerator 0? That should be pretty easy. What number makes the denominator 0? That should also be easy. Put that in a number line. Okay. Number 2 is a little bit tricky. Yeah, I don't mind telling you. For number 2, one of them is going to be open and one of them is going to be closed. Okay, so that's a hint I'll give you. Look back at the notes from yesterday if you're not sure how that works. But they're not both open and they're not both closed for number 2. One's open, one's closed. And then do the same thing. Pick a number in each region, region 1, region 2, region 3. Plug into the fraction. So again, you'll get something like positive divided by positive, or negative divided by negative, or positive divided by negative, something like that. Okay? And you know stuff like negative divided by negative is a positive, negative divided by positive is a negative, and so on. This time it's less than or equal to 0. So let's see, negatives are less than 0, positives are greater than 0. Okay? And once again, if the region's false, don't shade it in. And the region's true, then shade it in. And show me that graph, write the answer in interval notation. All right, so that's the quiz. Okay, open everything, open book, open notes. You want to talk about it, that's fine. Look it up on the internet. Okay, so all you got to do is work it out on paper, then get your cell phone and click, 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 take pictures on your cell phone and email it to me before 11:59. Right? So that's the way it goes. Right, so any quick questions about the quiz? I do want to make sure I cover the material, of course. So if the questions take too long, I might have to go on to.
Yeah, when we email you the quiz, so I don't remember if you went over it. In the subject line, do you need our G number or anything?
Yeah, I don't need your G number. Just put quiz 1, math 222 or something like that. I think I know, well, if you're using your My SMCCD account, it should show your name on it. But yeah, it'd be good to put your name in the actual email. So my name is John Doe or whatever.
Okay.
But sometimes from the email, I can't tell your name. But if it's obvious.
Okay.
Then,
Okay, thank you.
Right, you're welcome. All right, so that's that. Let me go back and do some more problems from last time. In fact, I'll go ahead and tell you for the quiz, yeah, look at stuff like this. In fact, this one's a little bit harder because there's what, 4 regions? And this one even had 5 regions. So look at what we did here yesterday. And look at what we did here. This had 5 regions. The ones that I'm giving you, I think it only has 3 regions. All right, so some more problems. 57, let me set you up with that. 1 over x is less than or equal to 5. I wasn't going to show you the whole thing, but I'll just get you started on it. There are only 2 questions for the quiz, correct? Just those 2. Okay. So how do I do 1 over x is less than or equal to 5? Okay, now on the right-hand side, you always have to have a 0. Okay, see how this was 0, 0, right? So what do I do if I don't have a 0? You make it a 0. Okay. So how do I change it to a 0? Well, subtract 5. So 1 over x minus 5. And now I need a common denominator. 5 is like 5 over 1. I multiply top and bottom by x. So it gives me 1 minus 5x over x is less than or equal to 0. And etc. So you work out the rest of that. Okay. So what number makes the bottom 0? 0. What number makes the top 0? Well, you have to do a little bit of algebra. It comes out to be 1/5. You're saying 1 minus 5x over x is less than or equal to 0. So on your number line, you're going to be laying down 0 and 1/5. Okay. So the thing that's going to be a little bit tough about this is to come up with a number between 0 and 1/5. Okay. Question was asked to put the quiz questions back up. Sorry, I can't really do that easily now. You can watch the video. The video has it. And maybe if I have time later, I'll do that. But yeah, it's on the video. Okay. Can you think of a number between 0 and 1/5? Because when you have your number line, right? You got to do all this stuff.
I did 1/10.
So a number in between. Okay. Yes. 1/10 would work. That sort of gave away what I was going to say. But one option I was going to say is you can change it to a decimal. Right. So if you change it to a decimal, then you can tell like 1/5 as a decimal, you can punch in your calculator 0.2 and say, okay, 0.1.
That's exactly what I did.
Which happens to be 1/10. Yeah. So that's one way you can always do that. Okay. All right. And by the way, I'm the only one that gets to say etc. You guys don't put etc. on quiz or homework. I'm the only one that gets to say etc. Meaning that's as much as I was going to show you. I didn't want to show you anymore, but you finish it. Okay. So don't put etc. on a quiz or test. You got to finish it. Okay. All right, then some other problems at the end involving absolute value. So what do I do when there's absolute value? Oh, I don't even have the right page here. Okay, so starting with 61, 63 absolute value problems. So 63, absolute value of blah, blah, blah equals 2. Here's the logic I'm going to give you. I'm going to cover up what's inside the bars. But sometimes I try this trick. If you don't like looking at something, then cover it up. Don't even look at it. Okay? See, you might look at this and freak out and say, oh man, that's so complicated. Well, let me just go like this. Right? Does that make it easier? I've got my finger there. Absolute value of blah, blah, blah equals 2. Okay, then I ask myself, okay, behind my finger, what number or numbers would make it true? Now, I get a true statement if behind my finger was 2, right? But it would also be true if I have what other number? -2, correct? So behind my fingers, if it was 2, it's true because absolute value of 2 is 2. If behind my finger was -2, it's also true because the absolute value of -2 is 2, right? See, that tells me how to set it up, right? So now all this junk, there it is, I set it equal to -2 or same stuff equals 2. And I work out both of those. Okay, so now x minus 1, blah, 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 equals -2. X minus 1 over 2x plus 3 equals -2. Or x minus 1 over 2x plus 3 equals 2. Okay, so if I get something like this, equals 2, then I set it equal to -2 or 2. If I have absolute value of blah, blah, blah equals 7, then I set all of this equal to -7 or +7. Okay, and this should be straightforward. I don't like the fraction, so multiply both sides by the denominator, 2x plus 3, right? Multiply 2x plus 3, that cancels that out, and distribute this. So x minus 1 equals -2 times 2x plus 3. Distribute, that's going to be -4x minus 6. Okay, and then what did I do here? I added 4x to both sides, and I added 1 to both sides. So I try to get all the x's on the left side and all the numbers on this side, right? So plus 4x, that's 5x, plus 1, -5. 5x equals -5, divide by 5, I messed up here, x equals -1. And etc. here. So you do the same thing here. Algebra is pretty much the same. Multiply both sides by 2x plus 3, you get a different value. So x could be 2 possible numbers. One of them is -1, the other is whatever. Okay. So that's absolute value equals a number. A little bit harder if you have less than or equal to or greater than or equal to. That's more complicated. I will refer you to the text for what to do in those circumstances. Okay, so I'll just go ahead and mention on page 10. You don't really need this, distance from x1 to x2. So I would say don't put that on your formula sheet, cheat sheet. Midpoint formula. Remember, you get to have one cheat sheet, one formula sheet on the exam. Okay, standard 8.5 by 11, front and back. Put anything you want, but you can't put everything. So how do you find the midpoint? Just average the numbers. Okay, I think you already know how to average 2 numbers, right? How do you take the average of 2 numbers, add them up and divide by 2? Okay. So yes, you are allowed to put this on your cheat sheet, but that means there's less stuff for more important things. So if you can memorize the concept that the midpoint is just the average of the 2 numbers, add them up and divide by 2. But if you want to write down as a formula, that's fine. Same concept here for absolute value. Okay, so here's how you do absolute value inequalities. I would say don't look at all this stuff. So forget about that. Okay. These might be worth putting down. So where am I? Top of 11. How do I do absolute value of x is less than a? Absolute value of x is greater than a. I don't even like the way our author does this. It might be better to just look at this. I know what I'll do. This is what I think it's worth. Whoops. Okay, maybe you can't see it, so let me raise up the book. Absolute value of x is less than a, this picture. Absolute value of x is greater than a, is this picture. Essentially, for absolute value less than something, you're going to be between two numbers. Greater than or greater than or equal to, you're going out to both extremes, both negative infinity and positive infinity. Okay. I'll just mention quickly about the logic. Okay, so this is theoretical. Suppose this said 2. Absolute value of x is less than 2. That means 2 would not work. Negative 2 would not work. But 1 would be true. 0 would be true. Negative 1 would be true. 1.99999 is less than 2, and negative 1.999 would work, but nothing over here and nothing over here. This might be hard to explain. Maybe the easiest way for me to explain it is these two seem to be opposite, right? Less than, greater than, except for the equal sign. So it's almost like, well, whatever was true here becomes false here, and whatever was false here becomes true here. So it's almost like take the whole real number line and think of a whole switch of lights. All of these are turned on, all of these are off. And now you just switch the polarity, so to speak. All the offs become on, and all the ons become off, right? So all of these that used to be over here are now empty here, and these that used to be empty are now turned on, so to speak. You just switched the on and off, so to speak. So absolute value greater than looks like that and like that, which is x is less than negative a, or x is greater than a. Okay, again, I don't really like the way they put that. Okay. All right, so absolute value of x is less than a. You're between two numbers. Absolute value of x is greater than a. You're at the extremes. You're smaller than negative a or greater than positive a. And I'll show you how to do problems like that. All right, so we have stuff like that. And then, yeah, we have a few harder problems at the very end that we'll look at. Okay. 65. Absolute value of x minus 4 is less than or equal to 1. Okay, so that falls under the less than or less than or equal to category. Whoops. This one. So we are between two numbers. The two numbers being negative 1 and 1. So that means x minus 4 is between negative 1 and 1, less than or equal to, less than or equal to. Absolute value of x minus 4 less than or equal to 1. Then drop the bars, put negative 1 here, positive 1 here, less than or equal to, less than or equal to. By the way, on your cheat sheet, you're allowed to put sample problems also. Okay, so you're allowed to put down formulas, but if you want to say, you know, I don't remember how to do this. If you want to put this entire problem down, you're allowed to help you on the test. So negative 1 less than or equal to x minus 4 less than or equal to 1. All right, solve for x. So how do I get rid of minus 4? Plus 4, plus 4, plus 4. And that gives me 3 less than or equal to x less than or equal to 5. So in interval notation, 3, 5 is my solution set. So that means everything between 3 and 5 should work, and 3 also works, and 5 also works, but nothing else. Okay, now the problem's actually finished, but I'll dig a little deeper. I claim 5 should work. Let's try it. Plug in 5. 5 minus 4, 1. Absolute value of 1, 1. And 1 is less than or equal to 1. Okay, notice if you didn't have that line underneath it, right? Suppose it looked just like, whoops, look like that, then this would be open. Because then it would end up saying 1 is less than 1, and that's false. Okay, same thing for 3. 3 should work. 3 minus 4, negative 1. Absolute value of negative 1 is 1. 1 is less than or equal to 1. Okay, but again, if you didn't have that line underneath it, it would end up being 1 is less than 1. That's false. It would be parentheses. Okay, and that means stuff in between, like 4. 4 should work. 4 minus 4, 0. Absolute value of 0 is 0, less than or equal to 1, true. And how about, I don't know, 4.9, right? 4.9 should work. Let's see, 4.9 minus 4, 0.9. Absolute value of 0.9, less than or equal to 1, true. And I don't know, how about 3.5 should work. Let's try 3.5. 3.5 minus 4 is negative 0.5, whose absolute value is 0.5, and that's also less than or equal to 1. But a number like 6 should not work, right? And a number like 0 should not work. Let's try it. Try 6. 6 minus 4, 2. Absolute value of 2 is 2. 2 less than or equal to 1, false. And I claim 0 should not work. Let's try it. 0 minus 4, negative 4. Absolute value of negative 4 is 4. 4 less than or equal to 1, that's also false. Okay. So that's that. Okay, 69 was extremely tricky, actually. Where'd it go? 69, 1 over absolute value of x plus 5. Okay, so the first thing I do is, I don't like that absolute value, so I'm going to get it out of there. And the way to get it out of the denominator is multiply both sides by absolute value of x plus 5. But there's one little trick to that. Here was the original, right? Now remember, I'm never allowed to divide by 0. What value would make this thing 0? Negative 5, right? So x cannot be negative 5. I'll come back to that near the end. But I have to keep in the back of my mind, negative 5 is not allowed. Right? Because negative 5 plus 5 is 0. Absolute value of 0 is 0. And you can't divide by 0. Okay, so I'll keep in the back of my mind, x cannot be negative 5. Now I'm going to multiply both sides by the absolute value of x plus 5, which is a non-negative quantity, so I don't have to worry about changing signs. Okay, so that's just going to cancel out 1 greater than 2 absolute value of x plus 5. Divide both sides by 2. And now it looks like this. Okay, so that's the way I want it. 1/2 is greater than absolute value of x plus 5. Now, we're normally used to having the absolute value stuff on the left side. So how do I say the same statement, except this is over here and the half is over there? If 1/2 is greater than absolute value of x plus 5, that means the same thing as absolute value of x plus 5 is less than 1/2, correct? These say the same thing. Right? If A is greater than B, then B is less than A. Right, so now that looks like the previous problem. So you put x plus 5 in the middle, negative 1/2 there, positive 1/2 there. Now I subtract 5, minus 5, minus 5, minus 5. This is negative 5.5, this is negative 4.5, and x in the middle. So ordinarily, I would stop and say negative 5.5 less than x less than negative 4.5, which would be negative 5.5 to negative 4.5, but x cannot be negative 5. And negative 5 is in the middle right there. So I actually have to throw out the negative 5. So now this becomes my final answer. I'm going from negative 5.5 to negative 4.5, except I have to throw out negative 5. So this is the way I write it. From negative 5.5 to negative 5, union negative 5 to negative 4.5. So a very small portion of the real number line. Right? So if I look at only this, that's what I have. But I cannot have negative 5 in there, which is right in the middle. So my solution set looks like that. So you write it as negative 5.5 to negative 5, union negative 5 to negative 4.5. Okay, so that was a little bit tricky. Okay, in 67, is the greater than or equal to case, which means I do this. I have the two extremes. I have the number and its opposite, and I go out to infinity and negative infinity. So that means this. Absolute value of 3 minus x is greater than or equal to 2. So 3 minus x is less than or equal to negative 2, or 3 minus x is greater than or equal to 2. Okay, you're going out to negative infinity or positive infinity. So that is the application of this thing. So one more time, there's a 2 here. You want this expression here to be less than or equal to negative 2 or greater than or equal to 2. Now I just solve them. Subtract 3, subtract 3. Negative x is less than or equal to negative 5. Multiply both sides by negative 1. And recall what happens when you multiply by negative 1. Inequality symbol reverses. So x is greater than or equal to 5. Or over here, similar. Subtract 3, subtract 3. Negative x is less than or equal to negative 1. Multiply both sides by negative 1. X is less than or equal to 1. Right, so x is greater than or equal to 5. Close circle on 5, shade to the right. X is less than or equal to 1. Close circle on 1, shade to the left. So I have negative infinity 1 bracket. Union, you always use a U for union when you join one or more sets. Union bracket 5 comma infinity. And remember, negative infinity and positive infinity are always with parentheses. You never have brackets for infinity or negative infinity. Okay. For numbers, it could be bracket or parenthesis, depending on whether you have an open or closed circle. All right, then we have a couple of word problems at the end, 75 and 77.
Really quick, I'm a little confused on why number 65 includes 4, but number 67 or number 69 doesn't. I understand why number 69 doesn't include negative 5. I didn't see that, but like oh wait, because that's that because that would make it a denominator.
Correct. So the tricky thing there was the denominator is 0.
Yeah, but like when you switch it around, like yeah, that makes sense. Like, but when you switch it around, like you know, I mean, when you not switch around, like when you multiply out the fraction, right? And then you end up with, the absolute value of x plus 5 is less than 1/2. There's no denominator anymore. So like, why would you like not include negative 5?
Right. The original problem is like this. That's the thing. So once I do the rest of the problem, I still have to say negative 5 is not included.
Okay.
So,
all right.
I mean, to be very, very exact, what you're saying is correct. Because, yeah, when you multiply by absolute value of x plus 5, all of a sudden, the new statement allows for negative 5. But from the get-go, I know that's not true. So I have to say, okay, from the get-go, I already know x cannot be negative 5. You did some of those kinds of problems in Algebra 1. I don't know if you remember. Oh, I don't know if I can make up something.
No, okay, no, that makes
2
sense.
over
All right.
x equals 4. Okay, I know x cannot be 0, right? And
Yeah.
then if I multiply by x, I get this. Then all of a sudden there's no fraction and x equals 0 is allowed. But that wasn't the original question. The original question was this, and x equals 0 is not allowed. So yeah, by multiplying by absolute x plus 5, you're right. All of a sudden, negative 5 is allowed. So if the original problem was like this, negative 5 is allowed. Okay, but it isn't. The original was like this. So to be very, very exact, I mean, I should put down 1/2, or sorry, 1 greater than 2, blah, blah, blah. And x still cannot be negative 5, blah, blah, blah. And x cannot be negative 5, blah, blah, blah. And x cannot be negative. Well, that gets too tiring to keep writing it all the time. So I just kind of keep it in the back of my mind.
Okay, thank you.
Okay, so for 75, they said Fahrenheit was between 20 and 50. So here's what I do. 20 less than or equal to F, less than or equal to 50. What I do is force the thing in the middle to look like this. Then I'll change it to C. Okay, so what do you mean by that? Okay, see that F in the middle, right? I want to make it look like this. So first I'm going to subtract 32. Okay, so minus 32, minus 32, minus 32. So 20 minus 32 is a negative 12. The middle has F minus 32. And 15 minus 32 is 18. So if you ignore the 5/9 for the time being, ran out of fingers here, it now looks like this. Negative 12 less than or equal to F minus 32 less than or equal to 18. So right here, I subtracted 32. And now I multiply all three of them by 5/9. Okay, so what are you doing that for? I'm trying to force the middle thing to look like that, and then I change it to C. So 5/9 times negative 12, 5/9 times F minus 32, 5/9 times 18. Okay, and see, that's the idea. The middle now looks like 5/9 F minus 32, and that's equal to C. So I can get the range of the Celsius values. Okay, and what did I do here? A little bit of arithmetic. Negative 12/9 becomes negative 4/3. 5 times negative 4 divided by 3 is negative 20/3. The middle is now C, and 18 times 5/9 turns out to be 2 times 5 or 10. So C is between negative 20/3 and 10. So that's how that works. Okay. And now the dreaded 77. Okay, let's say you are contemplating investing $50,000 between two different investments. One of the investments is 5%, the other is 9%. You need a return of at least 7.5%. What is the maximum amount of the money that you can invest at the 5% rate? Okay, you're ultimately looking for amount of money at the 5% rate, so I call that X. So that X equals the amount at 5%. Now, do you recall this trick in algebra? The amount that you invest has to be 50,000 total. So if one of them is X, the other is 50,000 minus X. Do you remember doing a trick like that in algebra? Right. Two numbers have to add up to 20. So if one is X, the other was 20 minus X. Remember that? Or two numbers have to add up to, I don't know, 100. One is X. The other is 100 minus X. Right? So two numbers have to add up to 50,000. So one is X, the other is 50,000 minus X. So X, which is what I'm ultimately trying to find out, that's the amount at 5%. And 50,000 minus X is the amount at 9%. Okay, so now the return, the amount that you're going to make in interest is 5% of X, 0.05X, and then 9% of the rest, so 0.09 times 50,000 minus X. You want it to be at least 7.5%. At least means greater than or equal to, doesn't it? Greater than or equal to. Okay, that's the interpretation of at least. I know it sounds weird that you're actually doing greater than or equal to, even though it says at least, but think of it logically, okay? So you say, oh, Mary is at least 20 years old. Okay, Mary is at least 20 years old. That could be 20, 21, 22, 23, right? But not 19, 18. So it actually means greater than or equal to. Agree? Okay. So greater than or equal to, I need 7.5%. So 0.075 times the 50,000. So this is going to be my inequality for the setup. That was mostly the idea for the setup. Okay, then I just cleaned that up. 0.05x, 0.09 times 50,000 is 4,500 minus 0.9x, greater than or equal to, punch that in your calculator. You can always use a calculator for any quiz or test or homework. That comes out to be 3,750. Subtract 4,500 on both sides. 0.05x minus 0.09x is negative 0.04x. And let's see, that minus that comes out to be negative 750. Divide by negative 0.04. Divide by negative 0.04. Again, I'm dividing by a negative, so that switches the inequality. So x is less than or equal to. And then I punch out on my calculator, that divided by that is 18,750. X is less than or equal to 18,750. Now, if you look at the original question, what is the maximum amount of money that you can invest at 5%? I call it X, the amount of 5%. It's less than or equal to 18,750, right? So if the number is less than or equal to 18,750, the maximum, well, it's 18,750. So that answers the question. The maximum is 18,750. Okay. So that's the way that works. All right, let's see, still about 12 minutes. I'm actually done with everything I was going to do. I showed you the quiz. I'm not going to start 1.3, and I just realized 1.5 becomes extra. So I'm a little bit ahead now, as it turns out. But I'll just show you formulas you might want to put on your cheat sheet for 1.3, and then I'll start lecture on 1.3 on Monday. For 1.3, let me give you the things you might want to put on your formula sheet. It's on the coordinate plane topic. Okay, distance formula, page 16. If you're given 2 points in the plane, right, like that point and that point, how do you find the distance between the two? There's a formula. You can put this on your cheat sheet. Okay, in reality, most books put x2 minus x1 and y2 minus y1, but it's the same thing. I'm more used to that. So the distance between x1, y1 and x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. If you want to leave it like that, that's fine. Like, I'll just go ahead and write down what I'm used to and what I'll probably do most of the time. Besides, that kind of looks more like the formula for slope that you're used to, right? Formula for slope is, oh yeah, y2 minus y1, x2 minus x1. Believe it or not, you'll get the same answer. Okay. Now, x1 minus x2 is not the same as x2 minus x1. They're going to be opposites. But when you square them, it comes out the same. Like, suppose you have 3 minus 4. What's 3 minus 4? Negative 1. If I switch it around, 4 minus 3, that's positive 1. But in either case, when you square it, you get the same thing, 1. Right? How about like 10 and 5? 10 minus 5? 5. 5 minus 10, switch it around, negative 5. But in either case, when you square it, you get 25. Okay? So you can put it like this, but I'm going to go with this mostly. So square root of x2 minus x1 squared plus y2 minus y1 squared. And of course, the square root should still be there, actually. Okay, midpoint rule. Well, that kind of looks like what we had before. How do you find the midpoint between these two? Simple. You average the x's and you average the y's. So 1/2 of x1 plus x2, 1/2 of y1 plus y2. So you can put it on your formula sheet or not. I'll talk a little bit more about theory on Monday. And then we also have the equation of a circle. Okay, and you may have had this in your intermediate algebra class before. If I have a circle centered at HK and a radius of R, this is basically an application of the distance formula. You want all the points that are the same distance away from the center, HK, the distance being R. Okay. So they plugged into the distance formula and it ends up being like this. So maybe you want to put this on your formula sheet. Okay. The point XY lies in a circle with the center HK, when x minus h squared plus y minus k squared equals r squared. So it's a standard form of the equation of a circle. The center is HK, radius is r. Notice in the formula, the right-hand side is r squared. Okay, so let's say the right-hand side is 25. That's the square of the radius. So the radius itself would be the square root of 25 or 5. Okay, or let's pretend the right-hand side was 49. Then the radius is the square root of 49, which is 7. Now, sometimes the answer doesn't come out nice. Let's say the right-hand side is 13. Then the radius is just the square root of 13. You know, that's fine. Nothing wrong with that. Okay, and that's what we're going to do starting on Monday. Okay, so I'm finished, folks. So if you want to ask me any questions for the remaining time, you may. You can put in the chat or also mute yourself. Okay, so let's see. Will there be word problems on our exams? There'll be some word problems, perhaps. I don't give a lot of word problems. We haven't had a whole lot of word problems now, but I guess the last ones we had 75 and 77. Were kind of like word problems. So yes, word problems are fair game, but there'll be a small percentage for that. Okay. You email, scan of your quiz and the work. Yes, so show me all your steps. Always show all your work. When in doubt, do as much work as we showed you in class. Okay, so you've got the quiz. And yeah, somebody was asking for it again, so I think I can put it back up now. Okay, so here it is again. So I'll put it up again, do a quick screenshot or take a picture on your cell phone. Worst comes to worst, it's on the video. You can watch the video a little bit later. Show all your work. Get your cell phone, take a picture of your work, email it to me by 11:59 tonight. You had half a day, right? More than half a day. Open book, open note, open discussion. So quiz is not really the right word for it. It's more like just assignment, as it were. Okay. All right. Anybody else with a question? Either unmute yourself or put it in the chat. Otherwise, we are done. Let me stop the share for a moment so I can see the chat. I don't see anything. So I'll wait just a moment. Anybody else with anything, please? All right, seeing nothing and hearing nothing, we're finished. All right, have a good weekend, everybody. See you next time. Quiz due at 11:59
Thank you,
tonight.
Professor.
Take care.
Thank you, Professor.
All right,
Have a good one.
weekend.
Thank
Take
you.
care. Have a good weekend, everybody.